Hey, this is Andrew Brown from Exam Pro, and we are looking at composite SLAs. So we had said earlier that different services have different SLAs. And the problem with that is that when you have different services, different SLAs, it's kind of hard to understand what the actual guarantee is when you use them in combination. So composite SLAs is just a way of understanding what the actual SLA guarantee underneath is for the performance target. So imagine you have a web application, and that web application uses an SQL database. So the web app has a guarantee of 99.95% because maybe that's the performance target for the virtual machine, and then the SQL database is 99.99%. So what is it? Is it 99.95% or is it 4 nines? We don't know. So if we had to calculate that for the SLA with the web app and SQL database, that would come out to 99.94%. Don't ask me on the math. That is the example that we are given, but just understand that that's what it would come out to. It would come out to 99.94%. And so you'd have an overall reduction of the SLA, whereas the SQL database would have 99.9%. So how could we improve our SLA and consider that in our design so we get the SLA that we want? And so what you can do is you can add in fallback systems that will improve the overall SLA. And if you logically think about it, it makes sense why that would work. So imagine you have that SQL database and it goes down, but if you had a queue, and that queue was saving all the transaction attempts that the web app was trying to write to the database and saved in the queue, it wouldn't matter if the database went down because once the database went back up, all those transactions would be there, and then those transactions would then complete. And so by using the queue, which has a 99.9% uptime, based on the math down below, again, don't ask me how the math works, but the outcome would be an SLA of 99.95%. And so that's an improvement over 99.94%. So that is composite SLAs, and there you go.